I'll be honest, I'm kicking myself for the fundamental blunder in the previous video. In the previous video, I thought I had clearly established the remarkably high friction between the O-ring and the cylinder wall, and I had good reasons to think so. Or so I thought. Let me reiterate them. Although very remarkable, I was shocked by a loss of roughly 500 kg of compressive force at a pressure of about 100 bar. This disappointing value seemed to correspond reasonably well with a report on friction of nitrile rubber on dry polished steel. The standard calculations supported this view, and because I had tested my pressure gauge and my load cell beforehand, I had little reason to assume that something was wrong there. But I still had some questions. That's why I also presented my doubts to ChatGPT and Gemini. And when both AI systems subsequently supported my reasoning, I was quite sure of my case. It was the friction. Period. Overthinking, that was the trap I fell into. Not even, as I always like to do first, simplifying the situation or taking it to the extreme, which often exposes thinking errors. Fortunately, some readers questioned the measurement results and presented their arguments fairly convincingly. And then you sleep on it for a night, and suddenly, it's crystal clear, you've made a blunder. And for someone who is fond of physics, those are stupid mistakes he is not proud of. Instead of beautiful calculations about friction coefficients that coincidentally led to the desired results, first simplifying the situation would have quickly put me on the right track. What happens if the piston is stuck in the cylinder? Well, that's simple. If I pump oil into the cylinder, the pressure rises, but the piston doesn't move. And conversely, the oil pressure in that cylinder will certainly not rise if I try to push the piston in. And this last is the situation in my test. I press the piston into the cylinder, and if that piston was stuck, the pressure would not rise. And if that piston moved with difficulty, offering resistance, the pressure would be lower than expected. Not, never, higher. This is the essence. I made the fundamental mistake of considering this last situation, pushing the cylinder inwards, as equal to the situation in which the cylinder is pushed outwards by the rising oil pressure. However, they are each other's opposite. It is also a warning. Always thoroughly check the results that AI systems present to you. They were not helpful in this case. On the contrary. The consequence is, however, that there must be something wrong with one of my sensors, and I had tested them. Well, sort of. I was able to test the pressure gauge with my compressor and the values of the analog meter, and this digital one matched nicely. The same goes for the load cell. If I placed a 10 kilo lead ball on it, this sensor also indicated about 10 kilo. So I started testing again, and lo and behold, come and have a look. More than 2,000 years ago, Archimedes said, "Give me a place to stand, and I will move the earth." This wisdom is used here to exert a much greater force on the load cell using a lever and a weight of 10 kilo. Force 1 times arm 1 is equal to force 2 times arm 2. So torque 1 of 10 kilos times 24 centimeters must be balanced by torque 2 of 240 kilos times 1 centimeter. So in total, the load on the load cell must be about 250 kilos. But the display only shows 183 kilos, almost 27% too low. A 2 centimeter arm and a 26 centimeter arm should give a result of 140 kilo. But the display shows 103, that's 26% too low. 27.7 kilos, where it should be 30, and 80 kilos, where it should be 100. Further testing showed that the measured values varied wildly. For example, under an 80 kilo load, I read 40, 75, and 50 kilos in succession. It's clear, this load cell and display combination is seriously ill, and it's time for it to meet its maker. Back to China it goes. A new one from a different brand is already on its way. In the next video, you'll of course first see the results of the new pressure force measurements. I suspect that the friction will be much less than I assumed in the previous video, and that's a win. Just like the insight, everything should be made as simple as possible, but not simpler is a win. I thank my critical subscribers for their valuable input. Until next time.